Hi everyone. This video I just want to remind everybody about how exponents work, how powers work um, when we make some computations. So let's kick it off with say the number 2 and let's write down some of the powers of 2. So uh, you can always start if you wanted to start with non-negative numbers, you can always start with the zeroth power, um, and the zeroth power is by convention equal to of any non-zero numbers is just equal to 1. So we take 2 to the 0 is just 1. Um, this convention makes a lot of computations work in a particular way, so that the rules can work out well. If you take the first power uh, of any number, you should just get that number back. So this will be 2. Uh, Second power, well, what is that? So now we're getting into what how we can write this out. And here it's just 2 times 2. And I'm going to use dot, not the time symbol for multiplication. So this gives us 2 times 2, and 2 to the third power gives us 2 times 2 times 2 to the fourth power one more time, and so on. So each time we go up, we multiply again by another factor of 2. So if we go 2 to the capital N, where N is some big number, it means that we're multiplying 2 by itself that many times, N times. So sometimes you'll see people will write this down and then write just N times above it to denote that you've written that number N times in that multiplication. So, of course, we can evaluate this, right? We can see that this is going to be 1, 2, 4, 2 times 2 times 2 is 8, 16. And you can see these numbers are growing pretty rapidly, as you would guess. So a little language here is that this number, when we write 2 to the n, this number here is called the exponent. So that's something that you may hear when someone is talking about powers of a number. And there are certain rules that apply that might be useful to review as well. So if we have 2, let's give an example here, 2 to the power 3, sometimes said 2 cubed, and we multiply by 2 to the power 2, sometimes said 2 squared. Well, let's think about what this is. This is this, and this is this. And so we're multiplying 3 factors of 2 times 2 factors of 2. And so the total number of factors is going to be 3 plus 2, 5. And so this will give us this kind of expression that the exponents in this case will add. So this is going to be 2 to the 5th. And again, while the number up top is called the exponent, the number that's sort of the large number that you're taking the power of, this is called the base. And you need, in order for this to work, what we just did here, we need to have the same base here in there. So this is a general rule that you can apply, is that we get 2 to the a times 2 to the b is equal to 2 to the a plus b. Just in case, you can put any numbers, not just 3 and 2 in there, and this will work. Great. And one of the reasons we're looking at this right now is because in in some of the material that we went over this week, we're talking about the number of subsets of a given set. And it turns out that if we look at the number of subsets of a set with n elements, I'll write this down, then we get exactly 2 to the n power. That this is equal to 2 to the n. So this is an exponential scenario, exponential growth scenario. It just grows just that quickly. All right, so um, there's some other rules that you can imagine apply as well here. And those rules would be also this, that if I take a power and then I take a power of the power, that those powers multiply. So let's see if we can understand why that's true as well. The exponents, pardon me, the exponents multiply. So let's do this with this example here. So let's say I have 2 cubed, and I'll take this to say the 4th power. Okay, well, that means I'm going to take what's inside the parentheses, 2 cubed, and I'm going to take that to the 4th power. So what does that mean? That's 2 times 2 times 2 to the 4th power. Right? That's 2 cubed inside the parentheses now. And so what does that do? Well, let's just do it. It takes that number, 2 times 2 times 2, and it multiplies it by itself 4 times. Right? Oops. So, and as you can see, well, there are 4 groups of 3 2's, all multiplied together. And so that's 4 times 3, and that will tell us that we can multiply this 3 times 4. That will tell us that we can get this result, 2 to the 12th. So when you have a power of a power, the exponents multiply. Great. Um, and, there are other things that one can do here and that we may run into later, or if you have this appear in some other math course, you may want to be aware of it. So for example, you don't just have to take positive integers. You can also take negative integers. So if you have 2 to the negative 1, that is typically what it means is that you're taking the multiplicative inverse. Okay, well, that's fancy words, but one way you can think of it is if you have a negative, you can write 1 over 2 to that power. So this is 1 over 2 to the 1st power, which is just equal to 1/2. Let me move this down a bit so that it's symmetric. Similarly, if you took 2 to the negative 4th, right? Again, let me move this down. This is, you put 1 over 2 to the 4th, which is, 1 over 2 times 2 times 2 times 2, or 1 over 16. Right. So negative powers, you can also you can also compute. And as you can see, as that negative number gets sort of bigger, like -4 and -8, so on, as it gets very large in absolute terms, you get a very small number when you take that 2 to that, or any number to that exponent. So, and that's because you're going, 1/2 1/16, so on and so forth. So the denominator is getting very large. Um, I'll just mention it, but we probably won't run into it very much. You can also take fractions in the exponent. So for example, you can put 2 to the 1/2, and if you have 2 to the 1/2, well, how could we figure out what this would be? Well, we could kind of lean on a rule to try to figure out what this is. So let's look at this rule here, because I don't know what 2 to the 1/2 is. So let me call 2 to the 1/2 x as an unknown. Well, if I take x squared, what do I know? Well, x is 2 to the 1/2, so this is going to equal whatever this number is, x, it's going to equal 2 to the 1/2 squared. But from this rule up here, we know that when you take a power of a power, the exponents multiply. So this should be 2 to the 1/2 times 1, times 2, pardon me, which is 2 to the 1, which is 2. So whatever x is, x squared is 2. And usually what we call that then is the square root of 2. So you can take actually fractional exponents of positive numbers anyway, and you can get square roots and cube roots and all kinds of things. So there's more to the story with exponents than just um, multiplying a number by itself many times. You can get a lot of other things as well. I should say, of course, the base can be different as well. So I chose 2 because of this subset count that we were looking at uh, in the lecture this week. But you can also, of course, choose a different base like 3. So we could talk about 3 to the 5th, which is going to be 3 times 3 times 3 is 3, 5 times, right? So whatever your base is, when you take it to that power, you kind of multiply that base that many times. Um, so this is what some, 243 or something. All right. Okay, good. So hopefully this review gave you some good memories of exponents and powers. All right.